There are many statistical analyses that assume a variable is normally distributed. StatTools lets you test this assumption with its Normality tests group. This group has the three options you see here. The first two options run formal hypothesis tests, where the null hypothesis is that the variable is normally distributed. The QQ option is a more informal indication of normality or the lack of it. This video will illustrate these three options on the amount spent variable shown here. The chi-square test for normality is a simple one. It compares the histogram of the data with a histogram from a normal distribution with the same mean and standard deviation as in the data. If the fit is good, the chi-square test statistic will be fairly small, and the p-value of the test will be relatively large. Alternatively, a small p-value indicates that the null hypothesis of normality can be rejected. To run this test, you select chi-square test from normality tests, and you fill in the dialog box as shown here. You can choose the bins, or you can accept the default settings from StatTools. Be aware that the bin selection can make a difference. This is a potential downside of the chi-square test. The results can depend on the particular bins chosen. The results are shown here, both numerically and graphically. The very small p-value and the graphical results both strongly suggest that the amount spent variable is not normally distributed. The reason is its heavy skewness to the right. One common cure for this is to take the logarithm of the variable. I will do this and then rerun the test. Now I'll run it on the log amount. Here are the results. The log histogram, shown in blue, is much more bell-shaped than the original histogram, but the p-value is still very small. This means that you can still reject the null hypothesis that the log variable is normally distributed. This is a potential problem with any normality test. If you have a large number of observations, and there are 1,000 here, just about any deviation from normality is statistically significant. You might decide that the log of amount spent is sufficiently bell-shaped for all practical purposes. The chi-square test is not very powerful. This means that it is not likely to reject the null hypothesis of normality, even if the data suggest non-normality. This is especially true when the number of observations is small to moderate. The Lilliefors test is more powerful. It compares the cumulative distribution of the data to the cumulative distribution of a normal distribution with the same mean and standard deviation as the data. It has a special test statistic and critical values for deciding whether the data are significantly non-normal. This dialog box shows how you can test both the amount spent and its log with a Lilliefors test. Here are the results. Clearly, the cumulative distribution, the green one, for the log is closer to the cumulative of the normal, the blue, than the cumulative of the original data, red, is to the normal. This is reflected in the smaller test statistic for the log, 0.05 versus 0.11. However, each of these is larger than the critical values in boldface, so the bottom line is the same as for the chi-square test. The amount spent variable and its log are both significantly non-normal at all the usual levels of significance. The QQ normal plot, where each Q stands for quantile, is an informal graphical way to check for normality. It plots quantiles of the data versus quantiles of a normal distribution. If the normal fit is a good one, the plot should be close to a 45-degree line. Departures from this indicate some type of non-normality. I will first check the log of amount spent. This first option simply changes the scales of the axes. This second option shows a 45-degree reference line for comparison. Here is the resulting QQ plot. It indicates some mild departures from non-normality in the two tails of the log distribution. In contrast, I will show the QQ plot of the original amount spent variable. Now you see fairly extreme departures from normality in both tails and even in the middle. This is a typical indication of a distribution that is skewed to the right.